everyone. Welcome back to my math teaching online today. In this video, I will get right into the topics of the first lesson, the first chapter, and the first lesson in the second course of Introduction to Calculus. And the topic is antiderivatives. So what is antiderivative? Now, if you follow the mathematical concept from elementary up to now, we know that going forward is something and going backward is we doing something opposite, right? So that's the concept of the antiderivative. So let me show you example. If you have 5 and you add 3, like this is addition, right? So it gives you 8. So this is we call moving forward, right? 5 and 3 is 8. Now, how do you get back from A to 5? Then to move backward, if you notice that, you will see instead of adding, if you want to get back to the original, you subtract. So A subtract 5, A subtract 3 give you back to the original 5, right? So if you multiply, let's say if you have 6, you multiply 2, you got 12. So this is you move forward. How do you get back to 6? Then instead of multiply, you do divide. So 12 divided by 2 give you back to 6. Now follow this operation. If you have a function f of x and you move forward, you do derivative, you get f prime of x. So now if you want to go backward, just like this, what do? You do antiderivative, right? So instead of derivative, this we call a derivative. Now, if you go backwards, you call an antiderivative. So it's just a matter of moving forward and moving backward. However, because this is get into the higher level, right? And therefore, I told you, like at the beginning, I said, math is the sequence of steps from elementary, from adding, then subtract, multiply, and divide, right? Taking the power, powering it and taking the root backward. So now we go higher level, which is like math 12 and calculus. We're doing derivative. Now we're doing backward, which is antiderivative. So multiply back is forward, backward is divide. Adding is forward, backward is subtract, right? And then multiply is forward, and then backward is divide. So now we do derivative, forward, backward is antiderivative. So I can see this sequence is very familiar, right, at the beginning, right? Okay, so let's get into the question of how we're going to do the antiderivative, right? Because the higher level, so it has some notation, you got to be familiar with it, right? So let's say if you have a f prime function, right? You take derivative, you have a function f of x. You take derivative, you move forward, you have an f prime function. So now if you go backward, you have to undo what you already do to this function. And that undo we call an iteration. So therefore you have this notation, which is like a long S, right? And then you would take the antiderivative. So this is like antiderivative iteration of f prime of x. And you should have a dx, right? Because before we have dy over dx, right? So now it will give back to you the f of x function. And because we want to see the difference between the function original and the function original. This is also the original function, but we want to distinguish by making a big function like f, the capital F. So it like show us more obvious, oh, this is the original function, after we undo the process of the derivative, right? So now we use this notation. So basically, on the notation is just like this. Now, in a lot of textbook, instead of putting f graph x, which is I a little bit like confused, because why they don't put this notation in? Because we try to integrate the f graph x. We not try to integrate the original function. So I think, in my opinion, I think you should put an f graph here. But we already assume this is the f graph when we do. So a lot of textbook doesn't have this f graph here. But what they give you, it actually is the f graph function. It's not an fx function, it's the f graph function. But I think maybe they just want to simplify, so they didn't bother to put this in. Now I'm not sure about that, to be honest with you. I think that we should put an f graph here. But anyway, if you see something like that in the textbook, don't get confused. No, this is the f graph, and we try to integrate the f graph function, right? So the notation is f graph x of dx. You know what? Let me try another notation here, because we already know this notation. So I'm going to do like, instead of this, I would say dy over dx. So I'm going to call this dy over dx, right? Instead of f graph x, same thing, right? So this will give you the antiderivative and that will give you equal f of x function, the big capital F x, adding with c. Now I'm going to talking about why do we have a letter c in here, right? But that is the notation anyway, okay? So this is the notation, right? This is, we call it iteration. And when we do iteration of dy over dx, which is f graph x, then we get the back to the original function f of x plus c, in which this process we call an antiderivative. Now, let me show you why we have a c in here. So let's say if you have a function, let's say if you have a function f of x equal x squared. So when you take derivative of this function, right? Like, let's say we go forward like before to make it easy for you to understand, right? So let's say you have an original function x squared, and you take derivative of this original function, right? Let's say x squared plus 3. Then we take derivative of this function, it becomes 2x, right? Plus 0, and we don't have to write plus 0, right? Now, let's say if you have a function x squared minus 4, and you want to take derivative of this function moving forward again, right? We're talking about moving forward like we did before in the first course. So that we bring a 2 down here. So that also equal 2x plus 0, right? Minus 4 and t will be 0. So let's say if you have a function x squared plus 7, what it become? 2x. So basically, if we go backward, right? At this point, we will say, okay, so if we take the antiderivative, right? We integrate the function 2x. Let's say if we integrate the function f prime x, right? Prime x dx. Then, so we undo this, right? So we go here forward, now we go backward, right? Actually, this 2x, right? So then what do we get? We get x squared back again, right? Because this function is x squared. Now, but what is the number we're supposed to pick? Do we pick 3 here equal x squared because we go backward, right? So this is the forward, we get f prime x. Now we go from f prime x, integrate f prime x, we'll get back to the function f of x. And our f of x here, you see the original function, right? F of x. So we have, okay, so we got back to the function x squared, which is this one here. But do we put plus 7 or do we put minus 4 or do we put plus 3? We don't know. It could be any one of this, right? So therefore, we know that anytime we do the antiderivative, there will always be another constant c of this original function, except that that constant c is 7 or minus 4 or 3. We don't know. It could be any of this, right? So the antiderivative of 2x is the function original, which is x squared. However, we don't know. We don't know is that the x squared plus 7 or x squared minus 4. So we put in general, we say plus c. So make sure that you have a plus c here. Indicate that, oh, this is the original function. However, it might be another constant here, we don't know. So how do we know to find out the constant c so that we write out the original function? How do we know that? The only way you can find out the constant c equal what number if you are given enough information. So in the next sequence of lesson, I will show you how to get back to the original function, the result of our antiderivative, when you find out what is the constant c is, right? And that have to give you another piece of information. Maybe the initial position is something at the start, at the time equals 0, or, you know, the thing is, because if you have a function, let's say if you have a position function, s of t, right? If you know the initial, like if given you t equals 0, so when you throw the ball to the sky, right? That is actually this, the derivative of this, dy, the second derivative, dy over dx squared. So if you take the integration of this, it will give you back to you. Remember, in the motion I'm talking about in the first course, this is the position function. And when you throw the ball to the sky, your initial velocity could be you throw it very fast, or you throw it very slow, or you're not throwing it, you just drop the ball, right? So the initial function, the initial time will decide the constant c is here. What is the number is that? It depends on the initial position. So when you throw the ball, do you throw it with initial velocity very fast, or you just drop it, right? Now, remember, derivative. So derivative of position function will be velocity And if you take velocity, derivative of velocity, it will give you the rate of change of velocity, which is become an acceleration, the acceleration. So become a respect to t. So if you take derivative of velocity, it will give you the rate of change of velocity respect to time, which is become acceleration or deceleration, but we just put a for now, right? Acceleration. So this is the second differential equation because you have to do twice. You have to do anti twice to get back to the original. So let's say if you're talking about v prime t here, then d square y here is v prime t here, right? Dx square. So that will give you back to v prime of t. Now, if you take iteration of this v prime of t, which is dy over dx, will be, so this is the second differentiation. So this is go back to the original, the first differentiation, right? So you take the antiderivative or iteration of this, will get back to you the y function, and your y function is just s of t. So you have to iterate twice. You see that's why the square here come from. So this is, you take the second derivative, you take the iteration of the second differentiation, right? Then you get back to the v prime of t, which is dy over dx. And then you take iteration of the first one, you get back to initial position here, which is this cow as y, right? And this cow at y prime, and this cow as y double prime, right? Second derivative. So that's the idea when you move forward and you're moving backward. So I hope in my explanation here for you at the beginning give you a very solid foundation of what antiderivative means, right? And give yourself be familiar with this notation and how it works moving forward and moving backward. So now in the next lesson, I will show you the example of we actually take the antiderivative of a function and find out the c value. Okay, so I hope you enjoy my video, the first video. See you soon in the next video. Thank you for watching and bye for now.